So, first of all, let's see what this gives us. What is the first function? What is that going to give us? A parabola. What's the second function going to give us? A line. So a parabola a line can cross a parabola twice. Once it could be tangent to it, or none at all. Now remember, you need an x and a y when you get an answer to this. So one way we can do this is substitution. Say you solve this for y. Make life easy. Add x to both sides. Okay? And then substitute into this one, wherever you see y. So you're going to take your y out. You just have to be aware of your negative sign there. You can do that. Solve, distribute. Okay, we can subtract 1, combine these two. And how am I going to solve for x? Take factor out an x, pull an x out. So x is equal to 0, and x is equal to 2. So what does that tell us? How many times does this line cross the parabola? Twice. That's its x value. How am I going to find its y value? Oh, positive. Thank you. How am I going to find its y value? Okay, plug it in. This is the perfect spot to plug it in. We solved this for y. Don't forget, this is a parabola and a line. A solution is a point. It has an x and a y value. Don't hook these two x's up as a, this just says 2. So I plug in my 0, so y is negative 1. Here's my solution, 0, negative 1. I plug in my 2, y is equal to 1. Here's my solution, 2, 1. So I have 2 points that line is going to cross that parabola. And substitution, you can do it any way you like. I would not, however, solve for x because, well, you can, but then you'd have to go back here and FOIL this, then also plug it in there. That's probably a longer path to go through.
Why is that negative 1?
No, this is not, that's an equal sign.
The other one, the 0, 1?
Yeah, 0 minus 1 is negative 1. I took this equation, I plugged in the 0, right? Okay. 0 minus 1, negative 1. Okay. I tend to lose my negatives a lot when they're by an equal sign because they kind of all blend in, but that's an equal sign and a negative. Now, if you can set them both equal to y, you can always plug them in your calculator. You check it. You can always put the y's together if that's what you like to do. I know a lot of times traditionally kids like to solve these for y. They'll take the equation and solve it for y. One reason being you can check it in your calculator. Then subtract the 1. And they'll do this guy. So they add the x. Now, when you have an equation and they're both equal to y has to be the same value. You can set these equal to each other. Get everybody over to one side. Oops. Something's wrong.
It's x minus 1, not x plus 1.
X minus 1. Thank you. I'm got my calculators all over the place here today. So we get it all over to one side, and we're back to here. That's another way to do it. Yes?
Can't you, if the y's are both on one side, can't you subtract the equations from each other?
We're going to eliminate in a minute. Yeah, I was just thinking of other ways to do substitution. Like I said, like you could solve this for x to substitute in, which I wouldn't do, but you can absolutely do it. You can put your y's equal to each other, that's a substitution. A lot of kids like to do y equals because then how nice is this to check it in your calculator? You already have it y equal. You pull up your calculator, you do an intersect, and if you see if that's your right answer. So a lot of kids like to do that. Now, Denisha mentioned, well, if the y's are on the same side, why can't I do elimination? Remember, elimination is when you add them together to eliminate a variable. So elimination says, this is your elimination. You want to eliminate a variable. If I add these together, won't I cancel out the y's? Very nicely they'll cancel out. So I add down, a -1 and a -1 is a -2x. I add down, my y's are gone, and there goes my 1's. And aren't we back to where we were before? So there's a number of ways you can solve this. A number of ways. You don't have to match mine. When I do the homework, I do one way. But if you don't match mine, and yours is a sound way, you're fine. Just so that you recall substitution versus elimination. And elimination works really nicely when you have all your variables lined up. You can kind of spot it a little bit better. So we're okay with this part?
Yeah.
Okay.
That's all we're doing?
Now we're just doing a couple of these. We have 3 to do, 4 to do, and then you can do your homework. So they're not that bad. I was just trying to get a little variety, just to bring you back to, like, to your algebra parts. Because we spend so much time doing all these other things with angles and everything else that this kind of goes away. Now, you can do a substitution here, but you want to substitute when you can solve for one variable. You can even take this guy and divide everybody by 2. Now you can do a substitution if you like. But can I do this, right? Because I can multiply them all by 2. I can divide them all by 2, right? So to make life easy, maybe I see something here now that works a little bit better for me. Maybe I see, solve for x. Take my x and substitute that in. And solve. What are these both equations of? If I was going to put it in my calculator, what would they come out like if I solved them both for y? They would be both lines. A line can cross once or none. They can be parallel. Or it can have infinite points because it can be the same line. Or it could just cross once. So if you do this and distribute, we're going to do the elimination in a second. But there are many ways just to kind of get you used to seeing the different ways. So y is equal to -2. Now I got the y. How do I find the x? You plug it in, and look, we made a nice little equation. God bless you. So we take this, x is equal to 7 plus 2y. You now know the y. 7 plus 2 times -2. That gives us -4. So x is 3. Remember, the x has to come first. The x has to come first. Now, if you put these both into y equal, you can absolutely see if it works out for you. Now, another method is elimination. You can keep them just like they are. You don't have to reduce them. If you spot the reducing part, more power to you. You can do this. Now, when you eliminate, this is your goal. You want that coefficient to be the same multiple, opposite signs. Now, sometimes it works nicely. You can just multiply by a -1 or a -2 or a +3. Sometimes you have to multiply both. I tend to go for the ones that already have opposite signs, so I don't have to multiply by negatives. Because I always find negatives, believe it or not, when you do the equal sign, most kids forget the negative for some reason. Most kids forget to multiply across the equal sign. And you have a number of ways you can do this. Unfortunately, there's not an easy one, like just by multiplying one of these. So if I multiply the top by 4 and the bottom by 3, they'll both be multiples of 12. All the way across, you have to multiply. So 20x plus 12y equals 36. 6x minus 12y equals 42. Okay, now combine. 26x, there goes your y's, is equal to 78. Divide by 26, and x is equal to 3. Okay, now, unfortunately, to find a y, you have to go back to one of your original ones. We don't have a little shortcut one there. But you can put it in either one. So I'm just going to take the top one. What's nice about this is after you put it in one of them to solve, you can put it in the other one to check. So I'm going to substitute in my 3. So I get 15 plus 3y equals 9. Subtract 15. 3y equals negative 6. Therefore, y is equal to, that's a 3, negative 2. And again, you make your solution point. We only had our lines crossed in one point. Okay. If you wanted to take this one and that one and do that, absolutely fine too. There's, like I said, there's a number of ways to do this, as long as it's a sound way. And remember, with an equal sign, once you multiply, you have to multiply every term all the way across the equal sign. And only one way. You only have to do one way. Whatever way you see. That's why I'm saying, like, don't erase yours because you didn't do it the same way I solved it. There's more than one way. And I always find in this lesson, like, sometimes if you can't find your mistake, call me over, ask someone next to you to look at it, because I find with myself, I know what I put there, so I keep saying the same thing to myself, and in the meantime, where was my negative? I knew there was a negative there, but I just keep saying it to myself, but it was never there. So you tend to overlook your mistake. So just ask somebody else, can you look at this? What did I do wrong on this? That's the hardest part, is resolving your mistakes. Actually, the hardest part is correcting these tests. Okay. So what do we have here? What kind of functions are these? They're what? Linear. They're both linear. Good. We're going to make a line that can cross once or none. Or it could be the same line. Multiples. So, any suggestions? Anybody want to do this a certain way? Substitution. So what do you want to substitute for? Okay, we're going to solve for x. So let's add 2y to the other side. That works out nicely. Come here and substitute it in. Watch that negative 2. This is a nice method to do this because it also sets up your x equals for when you need to solve the other variable. So distribute. And we cancel out the 4y's. And we say, is that true? No. No. So, no solution. So let's see why this is no solution. Let's set this up as a line. I'm going to add x to the other side. I'm going to divide by negative 2. Okay, I'm going to solve for this guy as well. What would make us have no solution? What kind of lines would they have to be? Parallel lines. So I'm going to see what happens. Add my 2x to the other side. Divide by 4. 2 over 4, same as 1 over 2. Ah, what do you notice about these guys? Same slope, they're parallel. I have no solution. That's one of the advantages of always solving for y equals, but I wouldn't want to do that and put them equal to each other because you're left with a slew of fractions, unless, you know, you saw it right away that they were parallel lines. Okay? Could we do elimination to this guy? How would I set this up for elimination? To make a common multiple, so which one would you like to multiply?
2y and 4y.
Okay, so you want to multiply this by 2?
Yeah.
Okay, I'm going to bring it down here. Sorry, that doesn't belong there. So we notice what happens here. This cancels out, this cancels out. Whoa. Is that true? No. No solution. Okay. Now, if in fact we worked our way all the way down here and we found 5 equals 5, what would that mean? Well, no. What if I work this, like, what if these came out and this said 5 equals 5, like it came out to the same thing? That'd be all solutions, they were the same line. Okay? So if they work out to two different numbers, no solution. Whoa. That's pretty good, huh? Never saw that one before. Okay, and the last one. What kind of functions do we have here? Linear, 2 lines, they can cross once or none. So any solutions? Well, any way you want to attempt to solve this, what would you like to do? Okay, if we multiply the top.
Whoa.
It's so weird, this board. If we multiply the top by 2, what will that give us?
The same thing.
Look at that. It gave us the same line. Now, normally we wouldn't want to multiply it by 2 because we would want one of them to be different, right? So, but you did notice right here that it is the same exact line, right? But say we didn't see that, but we knew we had to eliminate 1. So what if we multiplied it by a negative 2? So in this case, you're going to come out and say negative 4x minus plus 2y equals negative 2. So out, out, out. 0 is equal to 0. Is that true?
Yeah.
Then that's all solutions. That's the same line. And as soon as Hetzel said multiply it by 2, we realized, oh, that's the same line. So it's all solutions.
We don't have page,
You didn't have this?
no, it says on the bottom, page 476 and 477. Oh, it's this one. Yeah.
Oh, no, yeah, just ignore that. Well, what happened is I used to use the book, and then my pre-calc honors kids complained, so I put everything out of the book onto a worksheet. Most of your, like a lot of your work is pre-calc honors work. Remember I told you it's the same coursework. Cut out a little few things, not cut out some things, but most of your work is the same, so you can always go to calculus. Well, if you guys were juniors, if you go to calculus as a junior, when you take pre-calc as a junior, and you go to calculus as a senior, Mercy College lets you buy back those credits. You can buy your pre-calc credits back. You can buy them if you take calculus. They messed up the 1/2 year course one. They changed the rule.
The econ, I know I can't buy the econ.
That's the one.
If I didn't take bio, I would still be in pre-calc honors. I just didn't do it because it was first period.
What does it mean by what happens when you have credit for college?
Like I don't understand. Like if you buy your credits, let's say you bought your US history. So when you go to college, usually almost every curriculum requires you have one history course. So most colleges, I would say most, the Ivy Leagues maybe not, but most colleges accept Mercy College courses. They accept the courses that the kids do in high school for college credit. So you only buy, it's like $50 a credit that you pay here, where Mercy College, they're like $1,000 a credit. So you're saving money by doing this. And a lot of our kids go into college with a good 15 to 24 credits. It's almost a whole year that they have under their belt. So even if you just took a couple, so say first semester, your first semester in college, or maybe a semester where you have like really busy, hectic classes, only take 4, because you already have 3 that you brought in with you. So you can take maybe 4 2 semesters for your first year, maybe take 4 each time, because you brought in 2 courses that they gave you credit for. They usually are pretty good about giving credit to common courses, which is why we offer a lot of the common ones. We don't offer the weird ones. They wouldn't take credit. And you have to bargain with your college. You have to show them sometimes they'll say, oh, that's not the same as ours. You have to go to Mercy College, print out what your course curriculum says, their description. You have to compare it to theirs. I've done that from when I was in college, and I've done it with my kids. For when they went to community college and for what credits from them. My kids use St. Thomas Aquinas. And it's the same type of thing. You go to a college and you transfer your St. Thomas Aquinas courses, and sometimes they'll come back and say, not the same course. So you fight for that. Or sometimes you say, okay, put it in as an elective. Because you can take 2, 4 electives, whatever, over the course of 4 years.
I go to St. John's.
St. John's accepts
They accept Mercy, but they make you take so many other stupid classes for no reason. I'm like, why?
What program are you in?
I applied cybersecurity.
Oh.
I got accepted to physician assistant, but then I was like, I don't really want to do this anymore. So I just
That's very different. Cybersecurity versus physicians.
Yeah, I wanted to do physician assistant. That's why I did bio, and that's why I was like, I can't go through this for another 5 years. I'm not doing it.
Well, that was a good decision to make.
That's why, because honestly, you only need, because I would have wanted for pre-med, or because they were like, you don't need to, like, have all these vigorous biology courses in your undergrad, because that's when you go to grad school if you study, like, your specific area. Like, I was talking to this lady, or for my Yale interview, I was talking to her because I was like, I don't even take AP Bio in high school, because it seems, like, miserable. So,
And Yale may not accept Mercy College credit.
yeah, I forgot to ask her about that, but she's like that. You don't have to take all these like crazy biology courses in your undergrad year. So if you have them in high school, just try to transfer them any way you can.
Okay, good.
Because you're gonna have to take like basic sciences, basic chem, and your hard stuff doesn't start until you go to grad school.
To your grad school. Like even I teach probability and statistics, which is Mercy College, but most of my kids don't buy credits. And I've had many kids come back that have taken the statistics class in their college, and they're like, oh, what a piece of cake. I aced the course, I helped the kids, because then you have a nice course to take and you're more comfortable taking it. Depends where you want your comfort level.
What happens when you like right now I applied to all the colleges that I applied to as the physics in my major. But what if you want to change it? Like, can you change it for your first year?
Some
You can change your
colleges,
major anytime you want.
but not for some colleges, you can't change it if you're like I did. I was supposed to finish it first, but St. John's lets you change it before you go.
Before you
but not for
start.
all colleges.
Don't start. Change your major before you start anything. Because they're going to print out, like, they're going to work up your whole schedule based on that major, and then you're going to start working at it, and then the next year change it right away. Contact them over the summer and say, before they make that schedule.
Yeah, that's not what I'm saying. You can change your major in college as many times as you
Well,
want.
you don't want to take it too many times. Just don't, well, if you do, just don't take your major courses. Take your core courses first. And then, like I suggested to my own children, like take something that interests you to see, do I like biology? My one son wanted to go do criminal justice, and he decided, I think I want to be a gym teacher. So, because he likes to coach, he plays basketball in college. And he said, I want to coach. So he said, I think I want to be a gym teacher. As soon as he took 1 semester of anatomy and physiology, whatever you take, he's like, I'm going to criminal justice. Yeah. I knew he wasn't my science kid. I had to throw earth science into him and bio into him. But you know what? That's how you take them. And then he didn't use it. He used it as an elective. So it was not wasted.
Yeah, like I understand like they're Catholic schools, so you have to take
Yes,
three
you have to take
theology
11
courses.
theology.
You know, you only have to take 3 theologies, and that's it. That's all you need to graduate. But if you want more, you take more. They make you take an introduction to New York City class. What the hell is that?
Oh,
Yeah,
and
and
because
how
you're
to
in the
do it.
city limits, yes.
I'm in Queens though. Like, what am I even doing in Manhattan every day?
No,
Class?
that's the city limits. You're in the city area.
Oh
Queens is
my
the city.
God. I was like, why am I doing it? I was like, why not?
But,
No, like, you can change it out for an art class. I was like, what's the point of that?
but every college usually has their own, like, sometimes they even offer one course that everybody takes, usually as a senior, to like get you acclimated going into the business world. I forget.
Can you see
the
my
name,
mom
but
went
it's
to
usually
school?
as a senior.
It's so funny. I was like,
Well, way back in my day, I had to pay for my college, so I went to this technical college that was about a half an hour from my house for computers. I went all year long for 2 years, and I had my associate's. Then when I started working,
That's how you become a
I got a job real fast because I had 112. I had every computer language you can think of. So I got a really good job very fast, and then my work paid for my college. So then I went to Mercer College, finished my 4 years, and then did my master's in computers at IU.
My mom's trying to get her master's right now, and her job is paying for it.
And you guys, my job paid for my master's. When I was at my first job, they paid based on like if you got an A, they paid 100%. If you got a B, they paid 80%. When I went to IBM, they paid everything and my books. And they paid everything for my master's.
that's what happened to my mom. She started working at, she was a computer programmer for Verizon for a long time, and she started when she was in college, and then once she like, when she first started, they didn't like do too much, but then when she like was really established, like, at Verizon, they paid for her like full school, like,
It's pretty nice.
geez, I work at Verizon, they well.
Usually wherever you go, like as long as it helps you in your career at that work. Like when I went to IBM, so I would be an analyst. I got my master's in programming and computers, business computers, like computer systems. I did so that I could be an analyst. And they paid for every single thing. And so
Yeah, that's what my mom
well, then I
I don't know if I
my
can
kids
do
get
that.
my
I used to sit there and watch my mom do
so
some
I
programming, like at her computer,
stopped working for
all
them.
those like
I
numbers
want
and
to be a
letters
teacher.
and
My mom's like, you
language.
better be a teacher because it's like paid vacation.
No, not really. You work for it. You work hard for it.
Yeah.
Yeah, you work hard for it. Let me tell you, you bring a lot of work home. A lot of work home. A lot. Some teachers work more at home than others. Any job. Okay, one of the programmer I used to bring people's programs home, fix their programs at home. And this guy. So let's see what he did here. So you solve for x. This x? That's y. You add y, that's plus y. That's what I say. Have someone else look at it. Right? You see the same thing every time you look at it. That's what happens.
Is there supposed to be a radical on number 15?
Oh, yes, there's a radical in there.
Yeah.
And you're gonna write it just that same way. Yep. There's a radical.
Number 15 is a radical.
Okay, so you got the one? You divided this by 2. Oh, you have to divide this by 2. Yeah. You'll get 0. And that will be all solutions.
I don't know which one's gonna go. Like, this is like more
Okay?
I'll keep it clear.
No. She told me no.
I'm joking.
Okay, then you can either use the substitution method. Like this one, these are 2 lines. So sometimes it's nice to say, can I solve this for y? If I add x to that side, y is equal to what? Y equals x. Then when I come up here, I can either replace the y with an x or the x with a y. And then solve that equation. So then I
I don't know how to like, I feel like I'm on
so
a
then take this.
but I don't know.
You're right, so like that's just unsure.
Mr.
So
Williams.
there's this equation.
I'm fucking scared to
And
ask
it says
why
y
I'm
equals y. We're gonna put
I
in
think
x.
like
one equation, one variable.
She just told
Yeah,
me.
but if you have x, right, no, you
have
have
this.
this.
Yeah.
Well, this is a parabola and a line, so you could have two. Divide this by -1 and then.
No, I'm trying to find the right.
Okay, divide this by -1. Don't
Oh.
Because what happens is it reverses itself when you go to do the calculus. You can decide what you like to, oh, this is really weird here. You can decide whatever it is which way you like to do. In some ways you're not going to get a choice, but other ways you will.